Okay, so let me share the screen. Okay, so here.
Oh, okay. We can always check this doc and then
Yeah.
find it. Okay.
Somehow it's not copying the right
It's
cell.
okay. I understood. Like you you have to start with search and ranking, or you finish that.
I somehow I can't really.
Yesterday, like we finished up to tagging.
Tagging.
And
And the last. Can you see the 8 p.m. IST group? The fourth
yeah,
row.
16:30, right?
Yeah.
Yeah, the saving member.
Yeah. But the link. Oh, okay, I get it. So the link. Okay, so this is Google tricking me because I changed only the text of the link and not the link target.
Oh, okay.
It actually happens with all of those. I mean, like if I paste a new link in there, it just changes the text, not the link target.
Oh, so you finished introduction, preliminaries, you started with data manipulation.
Yeah.
And in that 2.1.5. Okay.
Are you already familiar with that from other courses, maybe?
Yes, yes.
Or
This is Python, right?
yeah,
Broadcasting. Yeah.
like
Ah,
you're familiar with this already?
yes, yes.
Okay. Um,
Broadcasting, indexing and slicing, saving memory.
so
Now we have to start with conversion to other Python objects.
no, I was at saving memory. I didn't finish saving memory.
Okay.
Um, um, yeah, let's do that. Let's continue with saving memory.
So for 8 p.m. IST, did everyone join? Like yesterday,
No,
they were
no.
only Roy.
There's a Telegram chat. I can send you a link if you want.
No,
Or
it's okay. I'm not
no.
familiar with Telegram.
Okay. And I think they want to read on their own, and then
Okay.
I'm not sure if they will join again.
Okay.
Natarajan wrote something looking forward to the 12th. I'm not sure if he means joining this reading group on the 12th, like on Friday, or if I don't know. Like no, they have a
Maybe he will.
meeting day after tomorrow, June 12th.
Oh,
So I think
okay.
they will read on their own and then meet once a few days or once a week.
Okay, okay.
All right.
Then we'll start now, or should we wait
Yeah.
for Rowan?
I don't know. Like I can shoot Rowan a mail. I will pause sharing for that.
We can go for 1.5 hours, right? No problem with you. Or
Yeah, that's good. Um, 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 10:30 it's right?
Yeah, 10:30.
Okay. What about like you're already familiar with lots of the topics. Isn't it boring for you then?
No, because though I'm familiar, I'm not able to recollect many things when it is required. So, suppose like we get tasked for interviews, right? So
Yeah.
at that point of time, I'm not able to use this.
Okay.
So when I'm reading it again, many things like the concept is getting more clear,
Okay.
and I will be able to use it when there is a requirement.
Okay.
So,
Um,
so for an example, like we were discussing about errors, right?
yeah.
So I was not clear about the concept of L1 and L2 error only confining to regression and cross entropy being used for classification. So that, like, those things did not strike me before.
Okay. Yeah, like the repetition helps with learning. Yeah.
Yeah. And one, like, I have a friend who has been in this for like 4 to 5 years now. So what
Yeah.
he said was, every time we need to keep reading about this. Otherwise, these concepts are like you'll forget it. It is
Yeah.
not easy to stay in memory.
Yeah. What I just thought, because I was using a Google Colab before, um, and I think it would be better if we both work on the same Colab, you know? So like on the same screen. So I thought about using TeamViewer maybe. What do you think?
Okay, I'll try to install it.
There's also, but I think TeamViewer is the most. Um,
Yeah,
there's also,
I've had it in like Office. I had it before.
yeah.
I've not used it in my personal system. I'll install it.
Okay.
Because if it was Word, I remember Google Doc means both of us can type in simultaneously and it will get reflected.
Sorry, in the where in the Google Doc or?
In Google Doc, Doc as in the Word document,
Oh, yeah, 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 yeah. Like in contrast to the Colab.
yeah, there is
Yeah,
some difference there.
yeah. Maybe they need to let the Google Docs team work on Colab. Um, okay. I should actually conceal the password from screen sharing.
No, I
Wait,
haven't installed,
no,
so I'm just installing it.
I was just confused because I thought concealing the password from the screen sharing, but since I will be uploading the video later to YouTube, it's not like it's live streaming.
Oh, okay.
So I can just, I don't need to conceal it. Also get some water quickly.
Yeah.
Okay. Were you able to join via the team viewer?
Yes, I just completed installing. But my system is getting stuck because of it. It'll take a little time.
Okay.
Okay, now I have it. So you will have to share.
I already did in it. It's in the chat.
Okay. First, like I get a screen with email and password, so I have to create an account.
No. I didn't have to create an account. You can skip that probably.
Grant easy access. I'll just share my screen.
Yeah,
There
I
is
will
some
make you
issue.
host. Allow record. You can't share the screen, right? Without me making you
No,
host?
I'll be able to share, but you need to stop sharing it.
Okay. Oh, okay.
Oh, okay. No. This meeting has host disabled participant screen sharing.
Oh, I
So
don't.
you have to enable that.
How can I enable that?
Maybe if you click on share screen somewhere, or
Oh. Okay, so now you should be able to share screen.
yes.
I
Now
was
I can.
searching in the settings and the other settings, but it's like hidden there.
Yeah, here. So I'm getting this screen, and when I give grant easy access,
Okay, is it possible to resize that window? No, like.
no. I'll start once again and then see.
Okay, and you can also, like, it's broken. It looks just broken. Does it have more settings?
Uh, yes, these are the settings. So did you configure any of these?
No. No, I just hope that there could be uh, hmm.
Or it's okay, like you can type and then I can parallelly type in my collab.
Yeah,
And
okay, you can also
that
do
should
that.
work. Or if I'll try to reinstall this again and we'll see.
Yeah,
Maybe a restart might help. I don't know.
okay.
Yeah, I'll stop sharing. Okay.
I'll share screen for the
It's
video
okay.
upload.
Oh, okay, okay. Yeah, you will be.
Okay. Did you open the collab and the book already?
Oh no, no. After the team viewer being installed, the system got really slow.
Okay. Can you deinstall it?
Hello.
Yeah, and
Hello.
so we are on chapter uh, and
215, saving memory.
I mean the notebook is in which folder? Not preliminaries, right? Or,
Ah, yeah, yes, preliminaries, yes. Data
and
manipulation.
oh, I have index, ND array, probability.
But I found it easy to just create a notebook from like a empty notebook and then just type it.
Oh, okay. You are typing each one.
Yeah, just typing
Okay,
it.
okay. Okay. Yeah, then we'll do that. Okay, saving memory, right?
Yeah.
Yeah, you can start.
Yeah,
Is
okay.
Mandela in? Is he?
Mandela's also here. Maybe you should give him like a heads up that I'm recording this. Are you okay, Mandela? Are you okay with recording and uploading to YouTube?
What?
I'm recording the whole thing and then I upload it to YouTube later. Are you okay with that?
Recall this session.
Yes, this
Um,
session.
yeah,
This
yeah,
even our like if your video is there, it will also be uploaded when you
yeah.
talk.
I don't understand.
Okay, I will translate with Google Translate.
Let's try. Are you okay with me? Ah, yes, I see. I see. Yes, I okay.
Also, I wanted to say it in French. Êtes-vous d'accord avec moi pour enregistrer cette session? Je
Je la
le
télécharge
téléchargerai
sur
sur
YouTube
YouTube après
après
la
la
session.
session. Je vais-
D'accord?
Êtes-vous d'accord avec moi pour enregistrer cette session? Je la téléchargerai sur YouTube après la session. Ok, pas de souci.
Okay.
I'm agree
Uh,
with you.
okay.
Wow.
Um, okay, I should go ahead with reading. I also sent a link to
This
Mandela.
part.
Yeah. And you also are familiar with using Google Colab, Mandela?
No, I use Jupyter Notebook.
Okay. You have Torch installed?
Yes, and PyTorch.
PyTorch, yeah. Okay.
I'm use PyTorch for.
Where's the chat? Chat there. Okay.
ID.
The split pane on the Mac is broken. Can you see the chat, Mandela?
Yes, I see saving memory. I'm ready.
Do you want to read?
Save memory.
Yeah.
No problem. Try. Running operations can cause new memory to be allocated to those results. For example, if you write y equal x plus y, we will dereference the tensor that y used to point to an instead point y at the newly allocated memory. In the following example, we demonstrate this with Python. The Python's id function will give us the exact address and of the reference object in memory. After running y equal y plus x, we will find that id of y points to a different location. That is because Python first evaluate y plus x, allocating new memory for the result, and then makes y point to this new location in memory. Yes.
So I tried that in the collab, and it is indeed true. Okay.
Okay, so like in C++, it was that value of y used to get changed, but here y is dereferencing, like referencing to a new
Yeah.
point.
Yeah.
Yes.
Okay. Okay. We'll continue.
Yes. This might be undesirable for two reasons. First, we do not want to run around allocating memory unnecessarily all the time. In machine learning, we might have hundreds of megabytes of parameters and update all of them multiple times per second. Typically, we will want to perform these updates in place. Second, we might point at the same parameters from multiple variables. If we do not update in place, other reference will still point to the old memory location, making it possible for parts of your code to inadvertently reference stale parameters. Can you read the next?
Yeah, fortunately, performing in-place operations in MXNet is easy. I wonder why it says MXNet because I selected PyTorch.
No, the text doesn't change, only the code changes.
Sometimes the text changes when you go to the top.
Yes, yeah, I remember. I read the same thing twice in different names.
Yeah,
So maybe
sometimes
they are
it's,
just mentioning about MXNet here, and earlier it was about PyTorch.
was it about PyTorch? Saving memory.
It's the same for PyTorch.
No, I think it's a mistake in the
my point
book
of view. Oh yes.
because
Yeah,
from my
for
point
both
of view,
MXNet and PyTorch, it is written MXNet.
I will make a note on the forum.
PyTorch is very popular framework.
Yeah, because it is made by Facebook AI Research Lab, FAIR,
Yes.
FAIR.
Yes. It's very popular in research.
Yeah,
In research.
yeah, research.
Yes. Mm, uh, uh,
Mm, okay. Um,
collapse.
okay.
I was just running all the query because
Yeah.
otherwise, like in between, I don't have the value saved. Like my code will give wrong answers.
Okay. So you uploaded the notebook to Colab or?
No, no, I'm just running. Yeah, I finished. I finished. Um, yeah,
Um,
we can continue. So
okay,
cross and
so maybe we can just. I think it's the same in PyTorch. They just didn't change the name, so I think it's interchangeably. Maybe that's why it's.
yeah.
The code is also the same for both. Just yeah.
You
Okay.
can read the sentence once again because I just need to get the concept.
Yeah. Fortunately, performing in-place operations in PyTorch is easy. We can assign the result of an operation to a previously allocated array with slice notation. For example, EG is for example, correct?
Sorry? What is
Whenever
example?
there's EG, that's
Yeah, example. Yes.
it's the same as the example, right?
Yes, example.
We can assign the result of an operation to a previously allocated array with slice notation. For example, y in colon in square brackets equals expression. To illustrate this concept, we first create a new matrix Z with the same shape as another Y. Using zeros like to allocate a block of 0 entries. Okay. So zeros like creates a vector of the same size. That's hence the like. Yeah.
Yeah, but the values will be 0.
Yes.
Zeros
I think it's like a identity matrix, but we can assign different values. No,
okay.
0 value.
Print ID set. And I have to print out the ID again. Yeah, so the ID is the same.
Yeah. Earlier, what we did was z equal to x plus y. That means completely the dereferencing happens. But when you use a slicing, you are actually changing the values inside the memory, right?
Okay. Okay.
So yeah, suppose like say z is a list and x plus y is a string. So if you z is a integer number and x and y were strings, but you can on the next line give as z equal to x plus y, and z will take a sum of the strings value.
Okay.
So, but if you look at other programs, languages, that is not possible because z will be already assigned as an integer and it cannot point to any other data types. But here, since the dereferencing happened, that can change. But if you are trying to change the inside value using the slice, then it will throw error because it needs integer values itself. Did that make more confusing?
No, it just sometimes when I sometimes fade out, so I like I'm thinking about different things, so then I don't listen anymore actively.
Yeah, okay, yeah, I get it. We'll continue reading, or do you want to think about it more?
Yeah, I was wondering how it works in, like, it still has to change the values when it's doing the addition, like in memory, right? It has to change the memory, but it's changing in the same location, I guess. Like it's like it allocates like space to store, I don't know, n
So it's
32-bit
like
integers, and then it changes the integer values in place instead of creating a new memory location. Yeah.
yes, it's like if you consider like z as an array, And first the array will be pointing to one location, and only if you use the slicing, the values inside the arrays can change. If you simply use an equal to sign and then dereference it to some other value, then the whole thing changes its structure or data type itself.
Okay. Okay. I wonder how that works in detail, but like before, yeah, okay.
Here
But
this
yeah,
happens because Z is a matrix. First we are creating Z as a matrix, right? By taking zero
no,
values for,
I get that, but like, how's the
okay, in the back end how it happens, that's what you're
like the
saying.
x, yeah, like the x plus y, like it's returning a new object normally.
Yes.
And that object is stored as the value of Z
Yes.
when you are slicing.
Oh,
And
without slicing. It's the internal cook of Python of Torch. La cuisine interne.
It's just like in when I compare this to Ruby, then I would have like x plus y. So x would be a method defined on y, on x, on the
Operator
like
plus.
this.
Yes. But
And
it's the same. It's the same in C++.
yeah, and then it would like the actual method, like defx, def plus. It would actually return a new object here, and the ID of the object, like it would basically create a new object just for this calculation, which would then be used in the column, in the square brackets function to assign it to Z, and then get garbage collected. I'm
can
not
you explain that one more time?
yeah.
I lost in between.
So like there would also be Z like this, and there would also be this function, right? And then it gets like the new values. And then it would assign new values. And then since new values wouldn't be used, like after execution of this, new values will get garbage collected. And I think Python also uses garbage collection.
Yes.
Yeah, and those values will be assigned to Z's values, right?
Yeah.
Yeah.
And then
So yeah,
Z, the object ID of Z will stay the same, like in the example here.
yes.
But
So
yeah,
The object, the ID will remain same, correct.
Okay, but
But if you are using z equal to x plus y without slicing, instead of the value, garbage value going, its address will be referenced to z.
okay. And the reason, like, what is the reason they give for this? Two reasons. First, we do not want to run around allocating memory unnecessarily all the time.
Mm-hmm.
And then second, we might point at the same parameters from multiple variables. The same parameters from multiple variables.
Like a simple example, if I can say, is sometimes when we need to do swapping and all, we'll use 3 variables. Instead of that, like sometimes those variables are used repetitively by poor programming. So to avoid memory loss in such ways, they have made things like this. So that once, first, if we use z to assign x plus y, and then later you don't need that x plus y value and you need z for any other purpose, then you can free the memory that was being used for x plus y.
Yes.
Otherwise, we will have to assign and take a new variable and allocate a new memory.
Okay.
Like if you're not using that variable further in the program, means you can discard that memory. That is what they might be thinking about.
Okay, maybe this is also like I think I will understand it more in depth how it's working in the implementation. Like,
Yes, in the, for example, in the context of parallel programming, you may have two parallel programs that share same variables. Can you understand me?
Yes, yes.
Two programs that share the same variables. So each program has a variables that point to a same memory.
Mm-hmm.
Yes, I tried to explain this part.
I think you mentioned like 2 functions or 2 programs.
En fait, the parallel programming, do you know trade programming, concurrency programming?
No.
One program able to do parallel task at the same time.
I think, Manuel, we can read about this parallel programming and then try to correlate to this. Maybe as a homework, but we can do that.
Attends, je vais essayer
Maybe
de...
that can help us to understand better this concept.
okay.
So we'll just take a note in the chat so that parallel programming and congruent, what is it, Mandeep?
Concurrency programming.
So you mean when two parallel processes share the same memory, or?
Pas congruency, concurrency.
Concurrency, yes.
Yes. I try to translate my explanation.
Yeah, I was just wondering because this sounds like the second point sounds like something that should not, like in a higher level language like Python, should not occur. Like it should be fixed. If I'm like, I don't, that's why I was asking if I understand if I understand it correctly, but from the sound of it, sounds like something that should not even happen in the, like should be fixed in the implementation of Python.
What?
So you mean like multiple variables will be pointing to same values,
Yes.
and that will be like becoming some of the memory will become stale without being used. I think that is the thing that they explain here, right? Same values being referenced by different variables.
Yes.
And so that there will be a lot of memory that will be used.
A lot of what?
Is it what Manuel, what you got from that sentence? Can you explain?
Variables. Like, what's the, we might point at the same parameters from multiple variables. Does that mean it's something they will do because it's a good approach or because it's good practice? Or is it because, like, I don't get the sentence. Like, is it like...
They are trying to say that it can happen, like suppose we have an integer 5, okay, variable x and variable y are both having values as 5. So that is what they meant by we might point at the same parameter from multiple variables. But
Yes.
if you look at that, x and y have the
Can,
same value, and the memory, yeah.
Can you look at the screen sharing, and then I could type an example in the Colab.
Yeah, you can maybe p equal to 5.
P or?
P,
Yeah.
yeah, p for pan. P equal to 5.
Yeah.
And q equal to 5.
Q equal to P.
So now this is like both have same values, right?
Yeah.
But
The
two different
variables,
memories are being used for two different memory is being used for the same value to
the multiple
point to the same parameter.
to the same parameter, but to the same value. The value is different
Yeah.
of the
Two
parameters.
different memories are used to point to the same parameter.
Or
Now if you
to the
see
same
ID of
memory
P
location.
and ID of Q, it will be different values, right? Can you just print ID of P and ID of Q?
Yeah.
So here we, oh,
I think it's because it's, if I use string, it will be like, it's because it's an integer. Like integer all have the same memory location. Okay. No, but for string it's the same.
Same.
What?
So
How's it possible?
Try to pay
It's weird.
to touch tensor. Simple touch tensor.
Torch tensor. Now they have differing
Yes.
okay,
differing
here,
IDs.
because arrange is a random function, right?
It's from 0 to, like, it's a
to the parameter -1.
It's like a series from 0 to
Argument
in this case
one.
it's just one element, just 0.
Yes.
So yeah, but for P it will work in one way, and for Q it will work for another way. Now if you type again, you will see a different value, right? Just run it again. Now right now it is 13994884560 and those range. I'll just write it down.
No, it's differing now. You're right, it's differing now.
Yeah, now it's different. So every time a different memory is allocated.
Yes.
For the same function, different memory is allocated.
Okay.
That is how the torch works. Now,
But
why should it work like that is what we try to get from the sentence.
But they say second, we might point at the same parameters from multiple variables. And then I don't get the second part now. If we do not update in place, like if we don't do what they tell us to do, other references, like what do they mean with other references?
Okay, I think, suppose if P is a, like, now can you just print the values of P?
Yeah.
Just print P. Print P. Okay. So, okay, it's a tensor of zeros.
Same for Q. So they're both the same value.
Suppose that P is the important parameter of our models, and suppose that Q point to P, to parameter P, and try to change the update the value of P and look the value of Q.
Okay.
For see if one or another is changed.
Okay, so like I wish you could do it, or maybe you can do it, and I will share the collab. Can you do it?
So what he's trying to say is if P is equal to
send the
Q.
link. Yes, it's very good idea.
Okay.
And I think Mandela can share the screen, so.
Yeah, that's also.
Yes. In the chat, yes, I see a collab. I share my screen. My collab is white, very white. Share screen, yes.
But he has a black screen.
Oh, has it like a dark mode, or have I enabled some dark mode?
You have enabled the dark mode. We are having a white screen for
Which
I wonder where it did that.
Share. Can you see?
Yeah, this is even mine is like this. Yeah, we can see your screen.
Affichage. Je sais pas. On change le thème. Yes, I make my. Well, yes. This. Okay. Tac. I do Q equal P. Like that. I make some modification on P, like 2 P plus Q, and try to print the value of,
I think you should also print the value of Q before changing and after changing.
yes, the value of P. Da, da. No, I need to.
Just do one thing. There is execute from start. There is some in that execution menu. You can run
Yes.
all the things at one stretch.
Ah, yes, yes. I run the necessary. Oh, execute. Execute. Yes.
Restart and execute all.
Oh,
Yeah.
yes.
Okay. Now,
Oh, see, all is zero. It's not good. It's not good things.
No, wait. I'm still interested.
No, it's not good things. All value is zero.
But can you try? I think it's
no,
good
now
with
you
zero. I think
now
it's
you
good.
can just run this cell. It should work. Just run this cell.
This cell.
Yeah. No. Make it 2 and run only this cell. You don't need to execute from start.
Yes.
Okay.
Yes. Don't see.
See, here the values has changed now.
Yes. Q, P, Q. Yes. This is more useful.
And then you should print out the ID of P also before. Or the IDs of both maybe.
The ID of P.
Like copy these also.
Yes.
Yeah.
And paste here.
Yeah.
I think instead of Z, you can make it. There is a unnecessary Z being. That's fine.
Yes.
No, yeah, that is needed. Yeah, you can run this. So.
Okay, at the beginning, the IDs are actually the same because they're both pointing.
The two were pointing at the same memory location.
So let me check something. I will take over screen recording. Okay, so now it actually updated in place. Interesting. When I
the value of key is the same.
When I change this in place to for example.
Yes, it's not a good idea. Yes. The problem of size.
Oh yeah, okay. Okay, so changing one changes the other because it's both pointing to the same object.
Yes.
Okay, so it's not creating a copy for
And no new allocation change in place.
okay. But the y plus x is creating a
New copy.
copy. But now if I would do like this,
Yes. Tac.
so like now and before it gets assigned a new ID, but changing
now
it in,
ID.
In place.
now it's all okay.
It's
Now
very
the memory allocation doesn't happen, just the value is changing.
yes.
But like when we think about this one here, there's still, because they talk about saving memory, right? But actually, there is one object created here, right? Here in this, there's still one object created. Like I would expect this
No, because Q is also being changed, right?
creates a new tensor with new object ID, and then but it's like it's invisible, you know. It's not. It's never. It will never occur after that. Like this one is creating like a new
No,
new
like
tensor.
the memory is remaining same, right? So it's not actually like a new object is created in the same memory ID. What you said is right. A new object is being created.
I feel like we need a book about deep learning that teaches deep learning in C++ or C. I think that would help. That would be better. Like
But the
because
problem will be most of the implementations and what companies use are PyTorch now, more than C++ for deep learning.
okay. Okay. Or I just have to understand Python more thoroughly. Okay, let's go ahead.
It takes time, but actually there's a course in Coursera itself, Michigan's Python. I'll just search, and that course did really help me with it.
Okay. I feel it won't help if you share it. Like I won't do it. Like I'm really, really, really picky when it comes to like
Or
books.
Python, coding with Python in 10 days, 100 days. But there's a book like that.
No, I'm really, really picky. Like this is the first book since years that I'm trying.
Okay. But I think when you move forward, you'll get the hang of it. Don't worry.
Okay.
Okay, we'll continue to read.
Yeah. If the value of x is not reused in subsequent computation, we can also use x square square brackets colon equals.
1 minute. I'm
Yeah.
just not on the right page. Yeah, it's the value. Okay, got it. Continue.
X square brackets colon equals x plus y, or x plus equal sign y to reduce the memory overhead of the operation. Okay.
Okay, so x plus equal to y will perform as the slicing operation itself. But in other languages, it's not like that. Okay.
So those are both the same. It's doing the same thing in the background, or
Yes, that's what they say.
Okay. Okay, we can also verify it here before.
The ID remains the same because only the value of X has been changed, not the dereferencing didn't happen.
Oh yeah. So there. Yeah. Okay. Yeah, that's the goal is that ID is the same. Okay. And without the so this actually differs from X. So these are two different operations.
Yes, if you see X plus Y, it might
It's
change.
Oh,
two
okay.
different operators.
Okay.
It's the same in C++.
Okay. Okay. So I think Python is
It's a high level language.
yeah, it's like
Yeah, that is why we don't need this int, like we don't have to specify the data type before. The program itself understand if you assign a 5, it is an integer. If you assign a string, it is a string. So Python understands.
I think my problem is I compared it to Ruby, and I think Python takes a different approach to interpretation. So it has more like it feels really interpreted in comparison to Ruby. Like Ruby feels more like a real programming language. This feels really like scripting language.
Yes, I remember when I first heard of Python, they said it's just like writing English sentences. Most of the code lines will be like that.
Okay.
Forget all about Ruby.
Forget all about Ruby.
For learn Python.
Yeah, sometimes it's very confusing because I code sometimes on ROS and that use C++ more, and it's all confusing. Especially the call by reference method and call by value method.
Yeah.
That concept isn't here at all in Python.
Wouldn't it make more sense to use C in everywhere? Like
C++ because I just learned the programming first in that language, but I've never I worked mostly with SQLs. I've never been a full stack developer, so never made any app or anything like that.
okay. Conversion to other Python objects. Please, someone else read.
Yeah, I'll read. Sorry. 2.1.6 Conversion to other Python objects. Converting to a NumPy tensor or vice versa is easy. The converted results does not share memory. This minor inconvenience is actually quite important. When you perform operations on the CPU or on GPUs, you do not want PyTorch to halt computation, waiting to see whether the NumPy package of Python might want to be doing something else with the same chunk of memory. A equal to, so you're creating an NumPy array, and B is a torch tensor. So, and you're finding out the type, A and B. To convert a size1 tensor to a Python scalar, we can invoke the item function or Python's built-in functions. Okay, so A is a torch tensor 3.3.5. A dot item, float, and int of A. Okay, you are just printing A. A means it will show it is a tensor of value 3.500. If you want to find the value of the tensor, we need to use inbuilt function item. And here, because it is having a floating number inside, and you want to get that floating number, means you can use float of A. If you only want the integer part, you can use int of A.
Okay.
Is that clear?
Yeah.
Okay. Summary. The main interface to store and manipulate data for deep learning is the tensor, or the n-dimensional array. It provides a variety of functionalities, including basic mathematical operations, broadcasting, indexing, slicing, memory saving, and conversion to other Python objects. The exercises. Run the code in this section. Change the conditional statement x equal to y in this section to x less than y or x greater than y, and then see what kind of tensor you can get. Replace, we'll.
I think we should skip the first exercise.
Okay.
Or do you want to do it?
We'll do it, and if you find difficult, we'll discuss tomorrow. Like, we'll do it by ourselves, not now.
Yeah.
And so next is data pre-processing. So far, we have introduced a variety of techniques for manipulating data.
Sorry, we didn't read the second exercise.
Yeah, it's a continuation of that, right? Replace the two tensors that operate by element in broadcasting mechanism with other shapes. Example, three-dimensional. That actually we did here. Remember, we made that 0 to, you made it 9, 10, and made it a two-dimensional tensor. Earlier, we were having only zeros, right? Then we made it 0, 1.
So adding tensors of different sizes, basically.
Yeah, size. Yeah.
And then,
but apply broadcast to it. We didn't do broadcasting, but we can check.
No, I already, like, you're familiar, like, you feel comfortable with broadcasting?
Yes.
If you just
Yes. Okay.
Yes, me,
yeah.
I'm comfortable.
Okay, then we
with this.
can indeed skip also on the second exercise. Okay.
Yeah.
Just wanted to be sure. Okay.
It's powerful techniques.
Data pre-processing, right?
Mm-hmm.
Okay. So far, we have introduced a variety of techniques for manipulating data that are already stored in tensors. To apply deep learning to solving real-world problems, we often begin with pre-processing raw data, rather than those nicely prepared data in tensor format. Among popular data analytic tools in Python, the pandas package is commonly used. Like many other extension packages in the vast ecosystem of Python, pandas can work together with tensors. So we will briefly walk through steps for pre-processing raw data with pandas and converting them into the tensor format. We will cover more data pre-processing techniques in later chapter. 2.2.1.
Yes. Reading a data set. As an example, We begin by creating an artificial dataset that is stored in CSV, comma-separated values file. Data stored in other formats may be processed in similar ways. The following mkd if not exist function ensure that the directory ./data exists. The command save is a special mark where the following function, class or import statement save also in the D2L package, so that later we can directly invoke the mkd if not exist function without redefine it. Below we write the dataset row by row into a CSV file like this. To load the raw dataset from the create CSV file, we import the pandas package and invoke the read_cvs function. This dataset has 4 rows and 3 columns, where each row describes the number of rooms, the alley type, alley, and the price and of a house. Can you read the next?
What do you say? I think we can skip on that section.
Yeah, but
Do you
just
agree?
for like, do we have the data tiny house, whatever, what was the name? Tiny.csv. Do we have such a data with us?
You can click on the open in Google Colab. You can on the top right. You can open the notebook in Google Colab.
Qui partage son écran.
Okay, got it. Yeah. So this is just opening the loading the file to a data frame.
I see the 2 notebooks. I'm seeing 2 notebooks, 2 collabs.
In my here, the data processing. So you can click here, Colab, and then you can open the notebook in Colab.
Yes.
Or okay, where did we stop?
Here to load the raw data set. I can read. To load the raw data set from the created CSV file, we import the pandas package and invoke the read CSV function. This dataset has 4 rows and 3 columns, where each row describes the number of rooms, alley type, and the price of a house. So that's where we stop. So it's just converting to data frame, right?
Yeah, okay.
Yeah. Now next is handling the missing data.
Handling missing data. Yeah.
No, you can.
Mandela
I
is
just
next, right?
wanted,
Yeah.
I just want to say, like, I had an exercise for a company, and where they asked me to do this analysis. So this is exactly the steps we follow. First, we load the data, and then second, we'll handle the missing data. So we can
Yes.
keep
Okay.
it in.
It's my turn to read.
Yeah.
Yeah.
So handling the missing data. Note that not a number entry are missing value. To handle missing data, typical methods include imputation and deletion, where imputation replaces missing value with substitute ones, while deletion ignores missing values. Here we will consider imputation. By integer location-based indexing (ILOC), we split data into inputs and outputs, where the former takes the first two columns while the latter only keeps the last column. For numerical values in inputs that are missing, we replace the not a number entry with a means of the same column.
Can you read it once again, that sentence? Like the whole thing. I couldn't relate it.
The last sentence.
No, but that by integer location, like that concept didn't.
By integer location.
Yeah.
Sorry. By integer location based indexing, ILOC, we split data into inputs and outputs, where the former takes the first two columns while the latter only keep the last column. For numerical value in the inputs that are missing, we replace the not a number entries with a mean value of the same column. Yes, can you read the next?
Oh, okay. Here we are taking inputs and outputs.
Yes.
As input is the first two columns and output is the last two columns.
No, it's not inputs. No, it's not true in all cases. Output is generally the more important feature of data. Input is the first two columns, output is the last column, yes.
I understood it now. It took me like almost a minute or 2 minutes to understand the simple thing.
Can you explain? Like I didn't get it.
So okay, the mean I don't get actually. You were talking about the integer-based location-based indexing, or the first line of code or the second line of code?
First line of code.
First line of code.
First line is the same as slicing the NumPy array.
Yeah, it's just slicing the num rooms and alley and the price into two separate. Like the price is the predicted, like the y, and the num rooms and the alley is the bold x, like the vector x, like the inputs.
Yes.
Oh, okay, I got it.
Yeah,
now.
I think it's like you know the saying when you don't see the forest because of so many trees.
Yeah.
Yeah. And then inputs fill not a number, inputs mean, like,
Yeah, so here the mean is 4 plus 2, 6 by 2, 3.
oh,
So
okay, so it fills
Yes.
the missing data with the
with mean
average.
value. Yeah.
The
Oh, okay.
average, you can use the median value.
Yeah, then it will be instead of mean, it will use median, right?
Yes.
Yeah. Or there is another one, F fill, that is like forward filling. Whatever is in the, suppose it is 4, it will, like, for example, the first 0 will have, I don't know what 0 will get then, but 3 will have 4 because it is forward filling. Previous value will get.
Oh, so it will
Yeah, whatever is previous.
will it sort it before, or?
Forget what?
That I'm not sure. Like we need to actually load this data and see, because
Yeah. I will get some water. Be right back.
yeah.
Forget what?
No, he went to get water.
Yes. Water is a lie. It's a lie.
You have college now, Mandela?
No, I finish my hair.
Okay, so like the virus did not affect your class. Did you have exams and all, the final exams and all?
Online exam.
Online, okay.
Yes. Online course and online exam.
Okay.
For categorical or discrete
value.
values, in inputs we consider not a number as a category. Okay. Since the LA column only takes 2 types of categorical values, pave and not a number, pandas can automatically convert this column to 2 columns. LE pave and LE not a number. A row will LE type is pave will set values of LE pave and LE not a number to 1 and 0. A row with a missing LE type will set their values to 1 and 0.
This is one hot coding.
Yeah, one hot coding.
I don't think it's directly, is it really one hot encoding? I think it's like something, it's like the same, almost the same concept, but it's not direct, it's not really one hot encoding, right?
There is a category of one hot coding called binary hot coding, something like that. I forgot the name.
The function get dummies.
Okay.
Do this, do that.
Can you see the screen?
Yes.
I would have expected, like, if it was one hot encoding, I would have expected something like that. This is the num rooms, but I'm leaving the num rooms out, so it would be LA, and then it would be 1 0 for pave, and then
0 1.
Yeah.
For none.
And then, yeah, and then. but yeah, I think it's.
No, this need not necessarily be like represented using a 2-digit.
Okay.
It can be represented also using a single digit.
Okay.
If you take these kind of statistical data, categorical data, if there is only 2 category, they prefer 1 and 0 instead of 1 0 and 0 1, because the models can, like, if you at the end of the layer, if you use a like a softmax classifier or a ReLU function, then 1 0 will be better than a 1 0 0 1 value.
For multi-class classification.
Yeah.
So seeing it's already 1.5 hours, it's like 12 p.m. in India. Should we wrap it up now, or 12 a.m. Sorry, not p.m.
If you guys are okay, we can go for another half an hour also. I'm
Okay.
fine.
Okay. Yeah. Someone else, please.
I'll read. Yeah, I'll read. I lose in between. 2.2.3 conversion to tensor format. That's the one, right?
Yeah.
Now that all the entries in the inputs and outputs are numerical, they can be converted to the tensor format. Once data are in this format, they can be further manipulated with those tensor functionalities that we have introduced. So in PyTorch, import torch, x, the vector x and y is equal to torch.tensor input.values and torch.tensor output.values. So this, like I think you would have, this parallel assigning you would have discussed before, right?
Yeah.
Like here x takes the first value and y takes the value after the comma.
Yeah, it's also this similar in Ruby, or it's the same in Ruby.
Yeah.
Or
So
no, it's actually not, but yeah, but I'm familiar with it, yeah.
Okay, so x will have input value that is 3, 1, 0, 2, 0, 1. So these are the values and okay, output dot values.
Output those
Okay.
value return the
Yeah.
NumPy array.
Yeah, here
Or the
output
pandas.
data iloc they had used, right? Data iloc last two columns.
Yes, to
No,
separate.
latter keeps only the last column. So last column is what is the last column here? Okay, last column is price. Got it?
The price.
Yeah.
Yeah,
So the
okay.
price values are stored in Y values 127500106 like that. It's clear, right? No?
Yeah, it's clear. It's clear now, yeah.
Yeah. Okay.
Summary, like many other extension packages in the vast... So?
No, I'm sorry. When I just come back to this page, the index goes and I was about to read and then, sorry.
Oh, okay, no problem.
No, you can continue.
Okay, like many other extension packages in the vast ecosystem of Python, pandas can work together with tensors. Oh yeah, they use pandas here, right? At some point for reading the CSV, yeah.
Yeah, and creating the data frame.
Yes.
But that's implicit, right? The data frame is automatically...
Yeah, read CSV creates a data frame. There is another method to create a data frame. Like there is pd dot data frame, and then you can explicitly write the values. Also, you can change arrays, NumPy arrays to data frame like that.
Okay, so in contrast to the tensor, the data frame, is it always two-dimensional?
Yes, it's a matrix.
It's like a Google spreadsheet, basically.
Yes.
Yeah, okay. And so it can't have three dimensions. Okay.
Or It can have 3 columns and 3 rows, 4 columns, 4 rows, like that.
No, not. I mean, can it have a y-axis, like not y,
Yeah.
a z-axis, a z-axis? Sorry.
Yeah, no.
Or any other additional, like, is it n-dimensional or two-dimensional?
It is 2-dimensional because you cannot,
Two-dimensional.
like,
Okay.
you cannot have an image information like RGB values and then the pixel values, everything. That cannot be a data frame.
Okay, so can it only contain strings and integers, or?
Float. The data content can differ. It can.
Okay.
It's like spreadsheet. We can give any. It's the CSV file format. No?
Okay.
Yeah. Summary.
What is this get dummies? I just scrolled back to handling missing data.
Get
And
dumb
then
is for doing one-hot coding.
Is
Okay,
this?
yeah.
Does it do it automatically, or?
Yes, automatically.
That's a function.
You can you can read the documentation of this function.
Okay. Okay, so get dummies is a standard library function. It's nothing the
Yes.
authors have. Oh, okay. Imputation and deletion can be used to handle missing data. What is imputation?
Imputation is
Delete.
replacing the value. We replace,
okay.
right?
Okay.
No, remove.
Okay.
And deletion is remove.
No,
So the exercise,
imputation, like remove the data in the data set.
Okay.
no, imputation is, they have mentioned it earlier. Imputation is replacing.
Ah, yes. Deletion is remove.
Yeah, in 2.2.2, they've said typical imputation replaces missing values with substituted
It's
ones.
not the it's not the same
Yeah,
sense in French.
in
In
English they
French.
say impute means deletes, but here it is different value meaning.
In French, imputation, c'est comme break, couper, enlever.
Even in English,
It's
it is
confusing.
like, yeah.
It's deletion, imputation.
In Python, imputation is replacing.
Python is very bizarre language.
Yeah. Now next, next we're going to linear algebra. Mandela,
Okay.
you want to read?
Yes, no problem. Oui, linear algebra. I like algebra. 2.3 linear algebra. Now that we can store and manipulate data, let us briefly review the subset of basic linear algebra that you will need to understand and implement most of model covered in this book. Below, we will introduce the basic mathematical objects, arithmetics, and operation in linear algebra, expressing each of them through mathematical notation and the corresponding implementation in code. Next part, scalars. If you never studied linear algebra or machine learning, then your past experience with math probably consisting of thinking about one number at a time. And if you ever balance and check book or even paid for dinner at a restaurant, then you already know how to do basic things like adding and multiplying pairs of numbers. For example, The temperature in Palo Alto is 52 degrees Fahrenheit. Formally, we call value consisting of one numerical quantity scalars. If you want to convert this value to Celsius, the metric system's more sensible temperature scale, you will evaluate the expression C equal 5/9 times F minus 32, setting F to 52. In this equation, each of terms 5, 9, and 32 are scalar values. The placeholders C and F are called variables and they represent no scalar value. Can you read next?
Yeah. In this book, we adopt the mathematical notation where scalar variables are denoted by ordinary lower case letters, example x, y, and z. We denote the space of all continuous real-valued scalars by capital R. For expedience, we will punt on rigorous definitions of what precisely space is, but just remember for now that the expression x element of R is a formal way to say that x is a real valued scalar. The symbol E can be pronounced in and simply denotes membership in a set. Analogously, we could write x comma y element of set 0 comma 1 to state that x and y are numbers whose value can be only 0 or 1. A scalar is represented by a tensor with just one element. In the next snippet, we instantiate two scalars and perform some familiar arithmetic operations with them, namely addition, multiplication, division, and exponentiation. The PyTorch one.
Yeah.
Yeah, I'm reading from your screens.
Oh,
So
okay,
let's,
okay.
yeah. So import torch x equal to torch dot tensor 3 dot 3.0 and y is torch dot tensor 2.0. If you give x plus y, it is adding 3.0 and 2.0. That will give
One
tensor.
second. I
Yeah,
will open it in the
Colab.
Colab. Yeah.
Yeah, so import torch assigning x to be a tensor 3.0 and y is a tensor 2.0 and x plus y will give a tensor 5.0. X into y will give a tensor multiplication, multiplying the tensors and giving tensor 6.0 and x divided by y will give a tensor 1.5000 and x double star y is x raised to y, that is 3 raised to 2, which is a tensor 9. So that's clear, right?
Yeah.
Vectors. You can think of a vector as simply a list of scalar values.
Scalar.
We call these values the elements or entries or components of the vector. When a vector represents examples from a data set, their values hold some real-world significance. For example, if we were training a model to predict the risk that a loan defaults, we might associate each applicant with a vector whose components corresponds to their income, a length of employment, number of previous defaults, and other factors. if we were studying the risk of heart attacks hospital patients potentially face, we might represent each patient by a vector whose components capture their most recent vital signs, cholesterol levels, my minutes of exercise per day, etc. In math notation, we will usually denote vectors as bold-faced or lowercase letters. Example, bold-faced and lowercase letters. Examples, small x in bold, small y in bold, and z in bold. We work with vectors via one-dimensional tensors. In general, tensors can have arbitrary length subject to the memory limits of your machine. So if you give small x equal to torch.arrange 4, x is a tensor of 4 values, 0, 1, 2, and 3. We can refer to any element of a vector by using a subscript. For example, we can refer to the ith element of x by x subscript I. Note that element x subscript I is a scalar, so we do not boldface the font when referring to it. Extensive literature considers column vectors to be the default orientation of vectors. So does this book in math. A vector x can be written as x equal to a column vector of x1, x2, etc. up to xn. Yeah, where x1 up to xn are elements of the vector. In code, we access element by indexing to the tensor. So x of 3 will be the tensor 3. Length, dimensionality, and shape. Let us revisit some concepts from num-ref sec nd array. I think each snippet they had named it something, right? That is why they say SEC ND array.
Okay. Yeah. Section.
Section num ND array.
Yeah. Num ref. Yeah, and then they have names for the sections, and then they. When basically when binding the book or rendering the book.
Okay. Because for the last one, I can see like section label, example vector definition. Okay, we'll continue with it. Let us revisit the concept from secondary in ND array. A vector is just an array of numbers, and just as every array has a length, so does every vector. In math notation, if we want to say that a vector small bold x consists of n real valued scalars, we express this as x is an element of a real number set raised to n. The length of a vector is commonly called the dimension of the vector. As with an ordinary Python array, we can access the length of a tensor by calling Python's built-in len bracket function. So here len of x will give 4 because x is equal to arrange 4, right? So length of x is 4. 4 elements are there, correct?
Yeah.
Yeah. So like if you check on the right side of your here p, if you take p, length of p, it will be 2. Length of q will also be 2.
The length of P.
Here on the collab,
Yeah.
True, right?
Okay.
Yeah. When a tensor represents a vector with precisely one axis, we can also access its length via the dot shape. The shape is a tuple that lists the length dimensionality along each axis of the tensor. For tensors with just one axis, the shape is just one element. Okay, so here we said it's a one-dimensional array. So torch dot x dot shape will be a size 4. So here it should be 2, I guess.
Just one element, right?
Yeah.
Print
Here
x dot
t
shape.
dot shape, right?
Yeah.
I think here it should be 2.
Yeah.
Size
Okay.
2. This shape thing is like, it will take time to understand. Only when you get more dimensional metrics that will be more clear. I'm still confused, little confused in that. We'll go forward.
Yeah.
Note that the word dimension tends to get overloaded in these contexts, and this tends to confuse people. Yeah, about me. To clarify, we use the dimensionality of a vector or an axis to refer its length. That is, number of elements of a vector or an axis. However, we use the dimensionality of a tensor to refer to the number of axes that a tensor has. So,
Oh, okay. Yeah. Okay. Wait.
no,
Okay, now
they
it's
refer,
confusing me as well.
they
Now it's
refer the
confusing.
same word, right?
Yeah, like so for for a vector, it would be wait, to clarify, we use the dimensionality. Wait, that's not actually clarifying. We use the dimensionality of a vector or an axis to refer to its length. I'm confused with the whole thing, but I'm completely lost when they say or an axis.
We use the dimensionality of vector or an axis. Okay.
Is the axis
So
a synonym for vector or no?
So axis means here, like we have column. If you remember the old pricing data, right? Price and so if you're
Oh,
looking
like the
at
length.
one axis,
No.
the columns.
Yeah, like the length of the. Okay, yeah.
Okay,
Okay.
so when you that is what we read before, right? If you take a hospital case, each patient is a vector.
Okay, and then the dimensionality of a
Of a
tensor
tensor,
would be 4 if it has if it's a 4-dimensional tensor.
dimension refers to the number of axes that a tensor has. In this sense, dimensionality of a
So
tensor.
4-dimensional tensor would be torch, tensor, no, torch, arrange, 100, and then I would say, no, 100, and then I would say, no, we say 4 times 4 times 4 times 4. And then reshape, right? Is it reshape?
Yeah, you.
So this would be a 4-dimensional.
Yes, correct. So,
But it's confusing because I think it would be better if I say like a.
no, here this is confusing because, like, if you compare it with the pricing data, right, then it is confusing because both dimensionality of the vector and dimensionality of tensor is the same there. But in the case you have written here, inside, if you see, like each tensor has individually so many elements.
Yeah.
So that is different from the number of tensors there, number of columns there are.
Okay.
Like it will be more examples. Only when an example come, we can get the idea better. Maybe we'll
Okay.
just keep this in mind, and I think when we work with images and all, this will be more relevant. With the statistical data like housing price, that won't be much relevant.
Yeah.
Okay, matrices. Uh, oh, now it's 12:31. So we'll stop then. We'll start with matrices tomorrow.
Okay. Yeah. Okay. Let's do it. Yeah. You will join for 7 p.m.
Yeah,
again?
yeah. Tomorrow I'll
Yeah.
join for.
Okay.
It's 7 p.m. No. Tomorrow 8 p.m. will be. No, I mean
8 p.m. IST.
16:30 of yours. That
Oh,
will
okay.
happen.
Okay. That's the earliest you can make, right?
No, I'm actually available anytime.
Okay.
I can actually add one more session of this.
What would be like the earliest time for you to be available? Because
I think it will be my 5 or 4 p.m.
you're
because up
4
to
p.m.
1, like my up to 1 p.m. I have my like I have a neighbor coming here for the online class. So
Okay.
up to 1 p.m. I won't be free. Then I think it's the lunchtime. So
Okay.
and my 1 p.m. will be like your very early, I guess.
1
Like
p.m.
what is your timing? My
1 p.m. IST in IST. In it's 9:30. Yeah. Okay. But the earliest available would not be 1 p.m. or it would be 2 p.m. or something, or
2 p.m. Yeah.
2 p.m. Yeah, I think that would be great.
Okay, so we can have 2 p 2 p.m. The 1 hour then in your 16:30
Yeah.
and 1 in 7.
Yeah. Wait, like the earliest I had today was 11:30, so 3 p.m. India time.
Okay, that is fine for me. Actually, I can attend. Can you?
And
I'll take it.
but I'm like I have sometimes I have difficulties like with my sleeping schedule. So I maybe you can share your email and then I will write you and Mandela and Rohin um, when I expect to wake up tomorrow.
Okay,
Would that
can
be
you stop?
work?
Like, can you stop recording this? Then I'll share the email
Yeah.
ID chat here.
Or actually, maybe we should just schedule for 10:30, and then my sleeping schedule will adjust. Like I will set a alarm.
Like I'm available after your 10:30. I'm available for any time. You can choose your time.
Okay.
We can do
Okay.
3 rounds because more than 3, I think it will be difficult for us to manage all the other stuff.
Yeah.
3 rounds.
Okay.
And like this one, the last one, it can actually go up to 2 hours. It's fine for 2 hours.
Okay. Okay. Yeah. Let me stop the. Um, how do I stop the?
The record option is there. In the Zoom, you have to stop record.
Stop recording.
Or go to your view options on top. Yeah, near that, near the green, again on top.
Okay, on top. Here.
Oh,
Stop
no,
recording here.
yeah.
Okay.